Question 50. Which of the following is true of magnetism? Which of the following is true of magnetism? A. Iron filings cling mainly around the ends of the bar magnet. Everybody might rush to choose this as an option because everybody knows that anytime you have iron filings, they cling around what? The poles of what? Of your bar magnet. However, let's take a look at the question again. It didn't say it's true of magnets. It says true of magnetism. Don't forget, magnetism is a property. Magnet is a substance. So you choose your what? You choose your option wisely. Let's go for the next option. The freely suspended bar magnet comes to rest in the geographic north-south direction. That is very correct. So if you suspend a bar magnet, it will come in an orientation of what? North-south. North will be pointing up and the south will be pointing down. C. Light poles attract. Is that correct? Light poles actually what? Actually repel. Light poles actually repel. D. Lodestone is a non-magnetic oxide. What is lodestone? Before the name magnet even came to play, it was formerly known as lodestone. So if somebody doesn't want you to know or is trying to hide it away from you, magnet is also known as what? Lodestone. So somebody is telling you now that lodestone is a non-magnetic something. It's a counter-intuitive statement. So we wouldn't take that. So the correct option is going to be what? Is going to be B. The freely suspended bar magnet comes to rest in the geographic north and south direction. Don't forget, the reason why we are not choosing A is not because that statement is not correct. It's obviously correct, but it's correct for magnets, not for magnetism. Magnetism is a property. Magnet is a what? It's a substance. Next. 51. The angle between the magnetic meridian and the geographic meridian at a locality on the earth is the what? The angle between the magnetic meridian and the geographic meridian at a locality on the surface of the earth is called angle of declination. Angle of declination. Angle of inclination. So let's take a look at the options. Longitude of the locality is not part of it. B. Angle of inclination at the locality. Yes, that is the correct option. Angle of inclination. C. Latitude of the locality. No. D. Angle of declination of the locality. No, because angle of declination is the angle between the magnetic meridian and the what? And the horizontal. Is also known as what? Angle of dip or what? Magnetic declination. Those are the three names they call angle of declination. So I call it angle of declination, angle of dip, or magnetic declination. So the correct option here is going to be B. Angle of inclination. That's the angle between the magnetic meridian and the what? Geographic meridian. Next. 52. The sign of the charge on a charged glass rod may be determined with what? How do you determine the sign of a charge on a charged glass rod? A charged electroscope. B. An uncharged electroscope. C. A galvanometer. D. An electrometer. The first option says a charged electroscope. Yes, because if you charge an electroscope, it has the leaves are going to diverge. So the leaf of an electroscope when charged always diverge. So when you now bring a similar charge near the same electroscope, it diverges further. So generally we always put it this way, we say divergence increases when it is of the same charge. But if it is of opposite charge, divergence will decrease, means it will no more diverge. So literally only a charged electroscope can be used to do what? To check the charge or the sign of the charge on a charged glass rod. However, you have to come to ask a question. Does it mean that if an electroscope is not charged, you cannot use to detect whether a body is charged or not? Yeah, the answer is you are very right. You can use an electroscope, whether charged or not charged, to detect if a body is charged. However, you cannot use this to get the sign whether it's a positive charge or a negative charge unless the electroscope is what? Is charged. So the correct option is what? A. Next. Question 53. The mechanical advantage MA of an inclined plane depends on what? Is it its length, its height, the product of its length and height, the ratio of its length and its height? Is simply to say mechanical advantage so if you have an inclined plane, then you have the length of the inclined plane, call it L. And this is the horizontal and the height it makes. From the horizontal down to the height, we call it H. Then this is the angle the plane makes with the horizontal. Usually you say what? Generally we say velocity ratio of an inclined plane is what? Is L over H. L over H. And if you look at this very well, you're going to get to know that what? That this same L over H ratio, what does it represent? It actually represents that this, if you check opposite over hypotenuse, that is sine, right? So let's do something. Sine theta is going to give you what? Opposite H all over hypotenuse L. And what do we do? If I need to change this L H over L into L over H, what do I do? Simply I reverse this, the both sides. I just take reciprocal of both sides. That is 1 over sine theta equals what? L over H, which is the same thing as this, my velocity ratio. So that is it. So the ratio of the length to the what? To its height will give you the velocity ratio, or just 1 over sine of the angle of inclination between it and the what? And the ground. That will give you also the velocity ratio of an inclined plane. And don't forget, I just said velocity ratio. The question asks for mechanical advantage. It is not a mistake. The mechanical advantage of an inclined plane is the same thing as the velocity ratio, ideally. Only and only if there is a case of what? Friction. However, if there will be a case of friction, question will tell you if friction exists, then it's not 100% efficient. However, most times we assume that both mechanical advantage and velocity ratio of an inclined plane are always the same. So the correct answer still remained what? D, the ratio of its length and its height. Next. Question 54. In which of the following are the substances arranged in descending order of their thermal conductivity? It means how we arranging them in descending order. So the most thermally conductive material is what is first, followed by the lesser ones. So we all know that generally copper is what? Is a very good conductor of heat. Copper is a very good conductor of heat, followed by steel in this order, and least by what? Glass. So option A gives us, without any stress, the correct descending order of what? Of substances in order of thermal conductivities. Next. 55. The vacuum in the thermoflask helps to reduce heat transfer by what? The thermoflask, the popular thermoflask you use to keep your water at home so that it remains warm for a long period of time, it uses all 3 methods generally to what? To prevent heat losses. 1. The vacuum in the thermoflask. When you hear the word vacuum, I've told you something about some heat transfer that can take place through what? Through space or vacuum. So and the name we call it is what? Is radiation. So only radiation, when it comes to the vacuum in a thermoflask, only radiation can when heat has to be lost in a vacuum, that can only happen in form of what? In form of radiation. However, it does not mean that what? Heat cannot still be lost in the form of what? In the form of convection or conduction. So to prevent that, if you put vacuum, you are only restricting movement of what? Of matter or particles along in the thermoflask. So the correct option is what? Is both convection and conduction. Both convection and conduction, and that is option B, which is correct for the question 55. Next, question 56. Which of the following phenomena explains the fact that a house whose roof is coated with white paint will be cooler in the hot season than one coated with black paint? And this takes us to the three types of bodies we have. We have the black bodies, the white body, and the gray bodies. Now, what are white bodies? What are black bodies? What are gray bodies? Black bodies, like the names imply, they are literally dull, not necessarily black, but they can be dull colored bodies. Why do we call them black body, and what is their behavior? Their behavior is such that whenever they receive some heat, they absorb all of the heat, and they do what again? They can give it out. They can absorb, and they can do what? They can emit all of their heat. So that is a black body. I repeat, a black body is a body which absorbs all the heat incidental on it and can emit all of the heat that it has. It can give it out also. Then the white bodies are not a very good absorbers of heat, but they are good what? They are good reflectors of heat. So when heat is given to them, they take nothing. They take nothing from the heat. They just reflect it back to where it was coming from. So they literally are not going to get hotter when you give them heat. But the black bodies, because they absorb heat, they become hotter when they see heat. Then the gray body is just an intermediary between what? Between a good black body and a good what? White body. So they take some of the heat, they reflect the remaining, and they can as well emit some heat and at the same time radiate some heat. So when you have the roof of a house that is coated with white paint, then you have created a what? A white body. It means that most of the sun rays or most of the heat coming from the sun incidenting on that roof are going to be what? Are going to be reflected back. Then the people living in that house are going to feel that the house is what? Cooler, compared to if the roof of your house is painted black. Then it means that most of the heat coming from the sun or the surrounding would have been absorbed by this black roof, and then people inside that house, they feel the warmth, and that is the reason. So he says with black paint. Why? Because of what? Because of reflection. Because of reflection. So white bodies are good reflectors of heat. So that is D is the correct option. That's because of reflection. Next, 57. Which of the following instruments has a pure tone? Which of the following instruments has a pure tone? Your guitar, vibrating string, tuning fork, and C-ring. So your tuning fork has the purest of tones out of all this list. So the tones coming from the tuning fork are resonating in its purest form, and that's majorly the reason why we use it for most of our experiments. That's why we use it for most of our experiments. So the correct option is C for 57. Next, 58. The lowest note emitted by a straight string has a frequency of 40 Hz. Any lowest note emitted by any sound instrument, we call it what? The fundamental frequency. Alright? How many overtones are there between 40 Hz and 150 Hz? So we quickly take a look at how it works. It is a straight string. A straight string is also called a sonometer. Don't forget that they are also called what? Sonometer. So let's take a look at how it works. We've done for pipe in the previous question. Let's do for string now. In this case, you can say the minimum for any resonance to take place in a straight string is a loop. So let's create a loop. This is and another one. So let's say this is the length of the string, and you can see this is just half a circle. So the wavelength, the circle here is just at the half level. So remember, a circle is a complete oscillation. It comes like this, and don't forget this is a what? Stationary wave. So they have to be superimposed. So this side is just half of it. And how do we analyze it? We analyze it by taking a look at what? At the total length here as what? Lambda over 2, because it's half of the circle. So we cannot get the full wavelength but half wavelength. So you say L equals to lambda over 2. And it means that what? Lambda becomes what? 2L. Don't forget our formula equation. V equals to F lambda. And frequency of the first harmony, which is the minimum you can have, is going to be what? V over lambda. And that is what? And that is V over 2L. That's the first thing. Then we go again. The second case of resonance will happen in this case. The same length, don't forget, but this time around, it makes a complete circle. And you see the same length? However, then L here becomes what? Lambda, because it's a complete circle, so we give it the full lambda. And let's go. We go to our fundamental equation, which is still what? V equals to F lambda. Then our first what? Overtone will be what? Will be equals to V over lambda, which is what? V over L. And it means that what? If you look at this first fundamental frequency and this first overtone, what is it? It means that if I multiply my first overtone by 2, sorry, my fundamental frequency by 2, I get the first overtone. If you multiply F0 by 2 will come here, then it will cancel the 2, and then you have V over L. Generally, I can say my F1 equals to 2F0, and my F2 equals to 3F0. If you check for the next overtone, and it keeps on going, F3 equals to what? F3 equals to 4F0. And you can see that we have between 40 Hz and what? And 150 Hz. Let's take a look at how that works now. The first one is 40 Hz, which is my what? F0. The second one is F1, which is, that's the first overtone, 2F0, and that is 2 times 40, and that will be what? 80 Hz. The second one will be, that's the second overtone, which is the third harmony, is going to be what? 3F0, which is what? 3 times 40 Hz, and that is what? That is 120 Hz. And the next one is the F3, that is the fourth overtone, fourth harmony, which is what? The third overtone, and that will be what? 3, so it will be 4 here times 40, and this is what? 150, 160 Hz, which is far more than our range. So we cannot enter this third overtone, we cancel it out. Alright, so you can see that the first harmony, which is F0, is 40 Hz, and F1, which is the first overtone, meaning the second harmony, is what? 2 of F0, which is 2 times 40, we got what? 80 Hz. The next one, which is the second overtone and the third harmony, is 3 times F0, which is 3 times 40 Hz, and we got 120 Hz. However, the fourth one will be cancelled out. Oh, we are going to cancel it out because it's 160 Hz and it's above our range. So the 40 Hz cannot be considered because the question says between, and 40 Hz is not even an overtone, it's just a word, a harmonies. So we're going to consider only 80 and what? 120 Hz, meaning the correct option is 2. So we can only have 2 words, 2 overtones between 40 Hz and 150 Hz. So the correct option is B for question 58. Next. 59. Which of the following statements support the assumption that light travels in a straight line? And when the phenomenon by which light travels in a straight line, we call it what? Rectilinear propagation of light. I repeat, rectilinear propagation of light. And let's see the following options. Light can be diffracted, even though you say light can be diffracted, sound also can be what? Diffracted. So it's not only light that can be diffracted, sound can be diffracted. B, a source of light produces distinct shadows of opaque objects. C, I'll still come back to that. C, a source of light produces interference patterns on a suitably placed screen. D, light can be reflected. Even sound wave that is not moving on a straight line is also can also be what? Be reflected. So let's go back to when you hear a source of light producing distinct shadows of opaque objects. That is just the reason why we say is a phenomenon that can be explained by what? By rectilinear propagation of light, and that will take you to your what? To your eclipse. When you hear rectilinear propagation of light, think of what? Eclipse. That's shadow and eclipse. They are as a result of what? Light traveling on a straight line. That's why it can cast the shadow of one body on another body. For instance, eclipse of the moon or some lunar eclipse. So the correct option is option B. Next. Alright, question 60. An object 3.0 centimeter high is placed 60.0 centimeter from a converging lens whose focal length is 20.0 centimeter. Calculate the size of the image formed. So we're given that what? H of the object, height of the object is 3.0 centimeter, and U, which is the image distance from the lens, from the converging lens, is what? Is 60.0 centimeter. And we don't know V, but we know that we're given that F equals to what? Equals to 20.0 centimeter. And V is unknown. So is unknown. How do we find it? We use our mirror formula, that is 1 over F equals 1 over U plus 1 over V. It means that what? We need to say 1 over 20 equals to 1 over 60 minus 1 over V. With that, it means that what? 1 over V equals to, plus 1 over V. 1 over V equals to 1 over 20 minus 1 over 60. And this is going to be 60. 1 over V equals to 60 minus 20 all over 1 200. And this is what? 40 all over 1 200. And when you do that very well, you reverse both, that is taking reverse of both sides. You see, it's going to be 1 200 all over 40. With this, you can cancel out, and you're going to have 30.0 centimeter. It means that what? That my object distance is just, my image distance is just 30.0 centimeter. However, the question did not ask for image distance. It asks for what? For image height. So let's use our magnification formula to get our image height. How do we go about that? We know that what? Our magnification, which is image height over object height, is also given as what? Image distance over object distance. So with this, we can have HI equals to V multiplied by H naught all over U. With this, we can sort in our values, which is what? V, we got that to be 30 times H naught we're given to be 3, then divided by what? U, which was what? 60. And what do you have there? You can see 30 goes here 1, 30 goes here 2. So 3 over 2 is what? 1.5. That is my image height is what? 1.50 centimeter. So the correct option here is what? B. Next. Alright, 61. Two capacitances of 6 microfarad and 8 microfarad are connected in series. What additional capacitance must be connected in series with this combination to give a total of 3 microfarad? So we have looked at a question today where we have to say something or do something about what? Capacitor. So let's go straight to the point, and we have capacitors that are connected in series, and the values are given. So we're looking for a third value that can be connected in the same series so that we can have a total of 3 microfarad. And let's go So we say let the first one C1 was given as what? 6 microfarad, C2 8 microfarad, and Cx is the third one that we don't know, whose value we do not know. So we just call it Cx for an unknown. But we know that our C total is going to be what? Is going to be 3 microfarad, because the question says we want to have an arrangement where our total capacitance is going to be what? Is going to be 3 microfarad. So don't forget, everything will be what? Everything will be connected in series. So I can make this arrangement. So I can have my first capacitor, that is 6 microfarad, second capacitor 8 microfarad, third capacitor, which is Cx, but I don't know Cx, but that's not going to be a problem. I know that what 1 over C total, because capacitor connected in series is like your resistors connected in parallel, so it's going to be reciprocal. 1 over C total is 1 over C1 plus 1 over C2 plus 1 over Cx, and with that 1 over C total, which is 1 over 3, is going to be 1 over 6 plus 1 over 8 plus 1 over Cx. With this, we can say 1 over Cx equals to 1 over 3 minus 1 over 8 minus 1 over 6. Or you can say minus 1 over 6 minus 1 over 8. And here it will be easier, very much easier, if you can look at an SCM of all the 3 denominators and we multiply everything through by it to be a lot more easier. However, if this becomes not too handy, we can also find the SCM and go through the other way. So let's quickly say, we can see that 6 can go in 24, 8 can go in 24, and 3 can go in 24. So we multiply both sides by what? 24. And what are we going to be left with? We're going to add 24 times 1 over Cx equals to 24 times, that is going to be 24 over 3 minus 24 over 8 minus 24 over 6. And this is going to be 24 over Cx equals to, this is going to be 8 minus 3 minus 4. And this is going to be 24 all over Cx equals to what? 8 minus 3 is 5. 5 minus 4 is 1. So what do? We can cross multiply. And this gives me Cx to be what? 24 microfarad. So the correct option is what? Is C, 24 microfarad. And let's go next. Alright, we have in the above diagram, question 62. M and N are insulated metal spheres in contact. A negatively charged ebonite rod P is brought near M when M and N are what? Are separated, and the rod is taken away. Which of the following statements is correct? We don't have to go through the option. We can just tell ourselves what happens when a charged rod is brought to a sphere of metal that are either connected or not connected. We're going to look at it. Let's take a look at what happens there. So we say we have some sphere, and that is a sphere N, and we have another sphere N. And what happens? Connected stood up there, and there is a rod, an ebonite rod, which was negatively charged. So this ebonite rod is negatively charged and is laced with negatives. That's the meaning of what? Negatively charged. So it's full of negatives. Don't forget, before this ebonite rod is brought near M and N, the M and N were equipotential, meaning the potential of both M and N were the same, because literally they were not charged. The number of positive charge here is the same thing as what? The number of negative charge in either M or N. Now what happens when ebonite rod P is brought near N? When ebonite rod P is brought near N, as expected, don't forget your law of what? Electrostatic. Say like poles repel, unlike poles what? Attract. So all the negative charges inside this N will be what? Will be repelled off. It will be repelled off and it will be filled with what? With positive charge. To be repelled off, it means that M will become positively charged. Don't forget, I repeat, there are the same number of charges of positive and negative in this M before this rod P was brought near. So when P is brought near, this negative, because it's charged with negative, it will chase away all the negative counterpart that are in P, because they are going to repel. And what happens? The only charge that will be in M will be what? Will be positive. Now when this M also come in contact with what? With N, almost the same thing happens. The reverse case happen, right? All the positive will now move away, all the positive of N, then N becomes what? Negatively charged. So we know that M is going to be positively charged and N will be what? Negatively charged. So let's go there and see which one will give us our option. Both M, the option A says both M and N have acquired negative charge. No. Both M and N have acquired positive charge. No. M has acquired negative charge. No, M has never acquired negative charge. M has acquired positive charge and N negative charge. So the correct option is what? D. M has acquired positive charge and N negative charge. Next. Lesson 63. When a transformer has more secondary windings than primary winding, it's what? When a transformer, what is a transformer? A transformer is a device, an electrical device that is used to either step up or step down voltages. You can use it to step up or step down voltages. However, it's not only for voltages, it can also be used to step up or step down current. But the bone of contention in definition of a transformer is that it is of voltage. However, it is compensatory. If you step up voltage, then you reduce what? You reduce current. If you step down voltage, then it means what? You increase current, because you cannot generate power from transformer. You can only transform the power. It's either I want more of voltage than current, I use a step up transformer, or I need more of current than voltage, then I can use a step down transformer. Let's see the options. So when the secondary windings, when a transformer has more secondary windings, generally when the secondary winding is more than the primary winding, it means that generally it is a step up transformer. In reverse case, if the primary winding is more than the secondary winding, then we call it what? A step down transformer. A has a smaller secondary current. B has a greater power output. However, the power output is not affected. It's a function of what? It's not a function of the winding, but a function of the efficiency of the what? Of the transformer. So it is not part of the option we can consider as being a correct one. C is a step down transformer, like I said. Now don't forget, it says secondary has more winding than primary, so it should be a step up. So option C is not going to be a correct one. B increases the total energy output. Transformer does not increase energy output, it only transforms, so it does not increase energy output. So we go back to our what? Our A has a smaller secondary current. Because of what? Because it is going to have more voltage in the output. Mind you, it is compensatory. It is compensational. Because if voltage is increasing, you have to reduce current, or if current is increasing, you reduce voltage. Since it is a step up transformer, means the voltage is taking in, we have to do what? It will increase it when it's giving it out, then the current is taking it, will be what? Will become lower. So the correct option is what? Is A. A has a smaller secondary current. So that's the correct option there. Next. 64. Isotopes are nuclei which have, we all know this, isotopes are nuclei which have what? The same atomic number but different mass number. Why do they have different mass number? Because of variation in what? In their neutron. Don't forget that the nucleus of an element is consisting of a nucleon. What is a nucleon? A combination of a proton and what? A neutron. And the difference in neutron in isotopes, that's what makes the difference in the what? In the mass number of various isotopes of an element. That is just A, the same number of neutrons and electrons? No. B, equal number of electrons and protons? No. D, same atomic number but different number of neutrons? Yes, that is very correct, because another atomic number signifies what? The proton. So the C is the correct option for question 64. Next. Question 65. A radioactive sample initially contains n atoms. After 3 half-lives, the disintegration of atoms that are disintegrated is what? Let's take a look at this. Don't forget that what? That as radioactive substances they radiate, their mass become smaller, and that is what we call decay. So they decay. And what is half-life? Half-life is the time taken for half the initial mass present or initial substance present to what? To disintegrate or to remain. To disintegrate or to remain. And it is obvious that if you have 10 gram and after sometimes it's remaining 5 gram, you can say either 5 gram has gone or 5 gram is left. You just want to say one thing, you say the same thing in 2 different ways. So we can say half-life is the time taken for half the initial atom present to remain or to decay. So let's see how it works. It says after 3 half-life, it was n at 0 time. After the first half-life, it becomes what? N over 2. That's the first half-life. At what? At the first half-life. After the second half-life, this one too will also be divided into 2. Meaning what will be left is what? N over what? N over 4. And that is after the second half-life. Now after the third half-life, it becomes what? N over 8. And that is at the third half-life. For instance, if the question had said 4 half-lives, it means we go to 16, from 16 to 32, from 32 to 64, from 64 to 128, and so on. It's just the denominator being multiplied by what? 2. The denominator being multiplied by 2. So this is going to be what is what? What is remaining after what? After 3 half-lives. If n over 8 is remaining out of n, what has decayed? Obviously it is going to be what? 7n over 8. N minus n over 8 will give you 7n over 8. So the question says atoms that have disintegrated. It didn't say it that has remained. If it has said that is remaining, it would have just said n over 8. It is tempting to have gone there to choose n over 8, but it says the ones that have left. So you have n over 8 left after the 3 half-lives. So what has gone? N, the initial minus final. That's it. Then you say what? N minus n over 8. This is simply what? 7n over 8. That is what has disintegrated. And the correct option there becomes D. Next. 66. The direction of the magnetic field at a point in the vicinity of a bar magnet is the direction of the magnetic field at a point in the vicinity of a bar magnet is, let's go. A, always towards the north pole of the magnet? No. Let me clarify that. So when you have a bar magnet, for instance, you're going to have this. For instance, let's say let me just bring north here, south here, north here, south here. And don't forget, magnet does not exist as a monopole. A magnet exists as a dipole. What do we call dipole? Magnet will replicate its pole no matter how small amount it becomes. So if you keep cutting magnet, you keep getting north and south pole until the last entity that cannot be what? any much divisible. I believe you wouldn't want to go that extent into verifying that magnetic dipole is not negotiable. It is something that is there. However, there is no single magnet on this surface of the earth that has only one pole. When a magnet has a pole, a single pole alone, we call it monopole. There is a popular saying that what magnetic monopole does not exist. So you don't have a magnet that has only north pole without south pole, or only south pole without what north pole. Definitely magnets will exist as a what, as a two polar substance. That's what we call what, dipole. So this, there is what we call what, line of force, and another name for that is what, is flux. So there is a line, an imaginary line that is linking one pole to the other, and this line of force always moves from north to south. That's why I'm putting the direction. Always move from north to south, and it keeps doing that. It keeps doing that. It keeps doing that. It keeps doing that, and they must never cross one another. They do not cross one another. They keep doing that. That's one thing. They do not cross each other, and they always move from north to south. If you have a problem getting the direction with which they move, it's simple. Let me give you a small trick. Send, make your capital letter N in send to be what, N. Capital, I mean N is sent to what, capital. So you know that what, N means send. When you send, N pole is the one that is what, always sending. In the same way, let me do justice for the what, for the other pole. So I will call my receive. I will, don't mind me, I'm going to write it like this, receive. I don't want to write the what, the normal receive. I just write receive this way, so that we know that what is the south pole that we always receive flux, and this is the north pole that we what, that we send what, that we send flux. So that is it. They always move from north to what, to south, and their concentration or their density is directly proportional to the what, to the magnetic field strength. The more they are, the more they are concentrated. And another question I ask you, where is the magnetic flux much or most in the magnet? Is always at what, at the poles. So let's see, always towards the north pole? No, it moves away from the what, from the north pole. So that's not an option. Always away from the south pole? No, it's always what, towards the south pole. So that option also is not a correct one. See, along the line joining the point to the neutral point? No, it is not. However, you need to know what is a neutral point. You need to know what is a neutral point. A neutral point is a point in a region in a magnetic field where a point magnetic substance, but at that point feels no net magnetic attraction. And you might like, oh, is it possible? Let's take a look at this drawing now. Let me have my north pole. Let me have another north pole. So let me bring these two magnets together. As expected, they will repel, right? So this north pole is going to send. Don't forget, north will always send. This one too will always send. This one will send. This one will send. They keep sending until what? Until their strength cancelled out. And any substance you place at this point is not going to have any or feel any magnetic attraction. No magnetic attraction for any substance you put here, whether metal or any other magnetic substance. So this is what we call what, the neutral point. The neutral point, meaning that what, the two strengths of the two magnets cancel out. So they cancel out, and any substance you put at that point is not going to have any or feel any magnetic effect. So that is not true. Be in the direction from north pole towards the south pole. That is the correct option. You can see in direction from the north pole towards the south pole. That is correct option. So D is correct option for 66. Next, 67. When two parallel wires carry currents in opposite direction, the force on either wire is, you should know that when two wires carry current in what? In the same direction, then it will be what? Attraction. They will have an attraction sense of what? Of interaction. However, if it is in opposite direction, then it will be what? A repulsion. Let's take a look at this again. It says in opposite direction, so we are expecting the two wires to have what? Some repulsive interaction. Let's go. A away from the other, obviously, because it will be what? Repelling each other. Zero, it is not zero. Twice as much, we cannot dictate the what, or we cannot know the what? The quantity or the magnitude. C, B, towards the other wire. No, it's not an attraction, so it's always away. When it is what? It is the opposite direction. However, if it is in the same direction, it will be what? It will be towards each other. So 67 is A. Next. 68. A lorry travels 10 kilometers northwards. So we have a vector problem here, and we have a lorry that travels 10 kilometers northward. So northward is just up north, and it is 10 kilometers. 4 kilometers eastward, it now shows 10 kilometers, and this is eastward, this is 4 kilometers. Then 6 kilometers southward, it goes down 6 kilometers, and then 4 kilometers westward, it moves again 4 kilometers, and you see it is 4 kilometers he moved before. So this 4 kilometers will coincide with what? With his path he has traveled. So this is last 4 kilometers. And what do you see? The question says, what is the total displacement? Displacement is what? Is just the distance between his starting point and the what? And the what? And the finishing point. However, it is displacement, not distance. So if it were to be distance, we would have added all of this together. It is displacement. We are not interested in how you've gotten. We just need to know your direction between the first place you were and the final place you are. So literally, what are we going to see? You see that this is 6 kilometers. So if from here to here is 10 and from here to here is 6, definitely from here to here is definitely going to be what? 4 kilometers. And is due what? Is due north. Is due north. 4 kilometers due north. So the correct option is what? Is B, 4 kilometers due north. Next. 69. Two forces whose resultant is 100 Newton. So we have two forces whose resultant is 100 Newton are at right angles to each other. If one of them makes an angle of 30 degrees with the resultant, determine its magnitude. So we have two forces that are perpendicular to each other. Let's call this one P and let's call this one Q. Q perpendicular means what? Their angle of inclination is just 90 degrees. However, whenever two forces are perpendicular to each other, the resultant is always what? The hypotenuse of the what? Of our right angle triangle when we do what? Pythagoras theorem. So the resultant is going to be what? Is going to be towards any, and is going to have an angle to the horizontal as theta. So this is my resultant, F resultant. However, to get F resultant is not a problem. You simply know that what? F resultant by Pythagoras theorem is what? Square root of what? Q square plus what? P square. And with this, we can go again and look at the question. However, we were not given any of the forces, but the resultant was given. So I can say this is my F resultant, which is 100, is the same thing as what? Square root of Q squared plus P squared. Or I can take square root of both sides and say 100 squared equals what? Q squared plus P squared. That is my equation 1. I need to get a complementary equation. So to get the complementary equation, we need what? We need to go further to the second statement. The second statement says if one of the what? If one of them makes an angle of 30 degrees with the resultant, So there is one that makes angle 30 degrees with resultant, like we have indicated in the diagram. We are to determine its magnitude. So let's say when this happens, you say what? Opposite over what? Hypotenuse. So you're going to say this theta is not just theta, but what? 30 degrees. So I can say that opposite over adjacent, generally theta. So I can say tan 30 equals to opposite Q all over adjacent, which is P. Then I can say tan 30 is tan 30 plus tan 30 is 0.577. So I can say 0.577 equals to Q all over P. Then I can cross multiply and say 0.577P equals to what? Q. If I cross multiply, this is my what? Equation 2. Tan 30 equals to Q over P, and 0.577 equals to Q over P. If you cross multiply, you're going to see that what? 0.577P equals to Q. This is your equation 2. I have two equations and I have to do what? I have to solve them now. It's simple. I can square both sides. If I square both sides, what do I achieve? Let me square both sides of this equation. It means that what? So 0.577 squared will give me 0.333 P squared equals to what? Q squared. And now I can, instead of writing Q square and P square, I can choose one. Since Q square is this, so I can put it in equation 1. So from equation 1, what happens? I have what? 100 squared equals to, instead of writing Q square, I write what? 0.333 P squared plus your P square originally there. P squared. So what is common? P squared is common. So I have 100 squared equals to P squared into bracket 0.333 plus 1. And I can say 100 squared equals to 1.333 P squared. And how do I get my P? I just take the square root of both sides. When I take the square root of both sides, 1.333 square root of that is going to give me, that square root of 100 square is just 100, which is what? 1.1546P. So it means that to get P, I just say 100 divided by what? 1.1546, and 100 divided by this. So I have my P to be what? 86.61 Newton. So I look if I get any, and that is D. So the correct option is what? Option D. Next. Alright, we have a graph here. So to make it very clear, so I will draw that and explain the basics we need to get from there. So let's have this diagram, and we're going to have what? An arrow, and there is 1 here. This is 1. There is 3, which is this, and there is 2, which is 2. So let's quickly analyze the motion of these 3 bodies. Now look at 1. 1 is moving at a what? At a constant velocity. 1 is moving at a what? Constant velocity. What of 2? 2 is what? Is decelerating. 2 is what? Decelerating. That's why it's slanting down. But what of 3? 3 is accelerating. However, 3 is accelerating, and if you try to imagine where it was coming from, it shouldn't have done that without picking an origin. You can see 1 and 2, they have an origin from what? From the velocity or the distance axis x in m, and this is what? The f in s, that is like frequency or period. And you can just imagine I am extending this to the negative what? X axis, and you can see, you can trace it down to where it was coming from, and you can say that what? 3 was actually coming from the negative what? Axis. And let's take a look at the options. Graph 2 corresponds to the highest velocity. Graph 2 does not really correspond to the highest velocity. As a matter of fact, despite 3 has not given us any constant velocity, we can still say what? 3 is for now the highest velocity. And graph 1 corresponds to 0 velocity. No, graph 1 does not correspond to 0 velocity. It's obviously what? Uniform velocity. Graph 3 corresponds to a particle moving in the negative x direction. Yes, that is very, very correct. You can see when I trace it down, it was coming from what? A negative x direction, and that becomes what? The correct option. So the correct option here is what? C. Graph 3 corresponds to a particle moving in the negative x direction. Next. Alright, 71. A note is called an octave of another note when you call a note an octave of another note is when it is twice that note. When it is what? Its frequency is twice that note, we call it an octave. So we have it so soft that the first option is just giving us that now its frequency is twice that of the first note. That is when we call it what? An octave. Next. 72. Which of the following factors affect the speed of sound in air? We have temperature, we have pressure, we have frequency. Okay, let's take a look at each and every one of the options there. The first one is temperature. Yes, the higher the temperature of the body, the more the movement of speed of sound in that body. However, don't forget that speed of sound involves the movement of the what? Of the particles around that body. So when you increase the temperature of that body, you are thermally agitating the what? The particles of that body, making them to move, making the atom of the body to do what? To resonate faster, to move faster, and as such, you can say that increase in temperature affects the what? Speed of sound. Then what of pressure? Yes, pressure, because as you increase the pressure of the body, what happens? You have made sure that the space between one molecule of the body and the other is reduced, so that the rate of vibration for which sound wave is carried through becomes faster. So pressure is also what? Is also a factor that affects what? That affects the speed of sound in air. Question 3. Frequency. Frequency is not. Frequency is not, because frequency is inherent in the sound wave itself. So it's not a function of an external factor. Frequency is not. It is what? It is inherent in that energy that is moving by itself. So it is not what? It is not a function of the what? Of the it's not a factor that depends on the environment. So 1 only, it is not 1 only. 2 only, it is not 2 only. 1 and 2 only. Yes, 1 and 2 only. So the correct option is what? Is C. Next. Question 73. When heat is applied to one end of a metal rod, the molecules at the other end soon begin to vibrate with greater amplitude than before, because it has been transferred by what? By, when you hear the word metal rod, you know it has to do with what? With conduction. Because I told you in the previous question that what? Conduction is basically by what? Through a solid. So it has to be conduction. C is the correct option for that question. 73. Next. 74. Which of the following media allow the transmission of sound waves through them? Which of the following media allow the transmission of sound waves through them? It can be through air, yes. It can be through liquid, yes. It can be through solid. So sound wave can go through any of these 3 at the same time. So it means what? We will look for what? Option 1, 2, 3, which is what? D. D is the correct option for that question. Go to the next question. 75. A slight loading of tuning fork has the effect of what? So you ask yourself, if you load your tuning fork, what effect does it have on it? And you might have it not really that clear, that crystal clear to you. Or imagine you hold an iron pipe. Just imagine you hold an iron pipe and you strike it. When you strike this iron pipe, notice the intensity of sound that comes from it. Now try to sit down on the same pipe, or try to place some things on it. That is tantamount to what? Loading a what? A tuning fork. If you do this, try to strike it again, whether it will sound the same way it sounded in the first place. Obviously it sound becomes lower. So anytime you are loading a tuning fork, the sound it gives you is of lower intensity. Is of lower intensity. And don't forget, for sound wave, intensity is tantamount to what? To amplitude. So a sound wave with much amplitude has also much intensity. So let's take a look at this. Decreasing its amplitude, as good as that. It decreases what? Its amplitude. I told you intensity is the same thing as what? Amplitude. Increasing in amplitude, no. Decreasing its frequency does not affect the frequency. Increasing its frequency does not affect the frequency. So it only has to do with what? With amplitude. Next. 76. Two strings of the same length and under the same tension give notes or frequencies in the ratio 4:1. Two strings of the same length and under the same tension give notes or frequencies in the ratio 4:1. The masses of the strings are in the corresponding ratio of 1. Okay, let's take a look at how that works. Alright, let's have the for string. The equation of frequency is what? F equals to 1/2L square root of what? Tension over what? Specific mass, specific length rather. That is mass per unit length. We call it specific length. So this, since we have two nodes under the same tension, listen, they have the same length and they are under the same tension. What does it mean? It means forget this. Since they are the same, it's constant. The tension is also what? Constant. So I say F is now a function of what? Square root of what? 1/mu. 1/mu is what? Is the specific mass of the substance, which is mass per unit length. So I can rewrite this as what? F equals to square root of 1/mass over length, because this one is mass per unit length and we call it specific length, and it means that what? My F becomes square root of L over M. However, we can go again and look at the question. It says the masses of the string, so we are more interested in the masses of the string. So what do? We strike out the what? The length. Don't forget, the questions told us it was of the same length. So anything that is the same, we assume they are going to be what? Constant. And usually we're going to say square root of what? 1/m. So for the two strings, you're going to say F1 equals to 1/m1 under square root, and F2 equals to what? 1/m2 under square root. Now these are my guiding equation. Now let's take the ratio. Since the ratio of their frequencies is 4:1, it means that what? It means F1 all over F2 is equals to what? 4 all over 1. But from here, if we do that, we're going to see it as what? Square root 1/m1 all over square root 1/m2. Just from these two equations, and definitely we can say that 4/1 is the same thing as what? Square root of m2 all over m1. And if you square both sides, what happens? The square root of this one will cancel, this one becomes what? A square. So 4 squared all over 1 is going to be what? M2 all over M1. And what is 4 squared? 16 all over 1 equals to M2 all over M1. However, our ratio would have expected an answer that has to do with what? 16:1. No, it can't be 16:1 because originally it was F1 to F2. Now you are getting M2 to M1. It should be the word corresponding ratio has to take you back on track. It means that what? My M1 all over M2 is simply going to be what? 1 to 16. So that gives me what? Option D as the correct option for that question. Next. 77. To obtain a magnification of 2.5, how far should an object be placed from the pole of a thin converging lens or focal length 10.2 meter? Alright, so let's quickly take a look at another lens problem. By now, I believe you should pause the video and try to solve it on your own, because we've solved almost 3 problems on this same topic, so you should try and see whether you can do this on your own. However, you can now replay and let's see whether you are right or otherwise. So let's take a look at it again. To obtain magnification, so our n here is what? 2.5. How far should an object be placed? It tells you you are looking for what? Image distance, question mark, unknown. Then the focal length of the what of f equals to 10.20 meter. Don't forget, for a converging length, the focal length is always what? Positive. For a converging length, it is always positive. So, but don't forget, your magnification is V by U. So we say 2.5 equals to V all over U. So if I cross multiply, I have V equals to 2.5 U. Now I have V in terms of U. Let me go to my length formula. I have 1 over F equals to 1 over U plus 1 over V. With this, I can say 1 over 10.2 equals to 1 over U plus, instead of writing V, I write 2.5 U, 1 over 2.5 U. With this, the LCM here is going to be 2.5 U. I take U out, then I have 2.5 plus what? Plus 1. Then, which is what? 3.5 all over 2.5 U. Don't forget there is what? There is also U here. So it is here. So I have 1 over 10.2 equals to 3.5 all over 2.5 U. I can cross multiply. It means that my what? It implies that 2.5 U equals to 10.2 times 3.5. And when you do this, let's go 2.5 U equals to 10.2 multiplied by 3.5, and that is 35.7, and U becomes 35.7 divided by 2.5, and U becomes 35.7 divided by 2.5, and this gives me 14.28 meter. That is my what? My object distance. Don't forget, it is the object distance that was asked. To obtain a magnification of this, how far should an object be placed from the pole of a thin converging length or focal length 10.2 and So let's go for question 77. To obtain a magnification of 2.5, how far should an object be placed from the pole of a thin converging length of focal length 10.20 meter? This is another length problem, and we already are given that the what? That the focal length. We are given the magnification, and the magnification is 2.5. F equals 2.5, and an object is placed from the pole. That is, we are looking for what? Image distance. That is, object distance, and we were told that what? The focal length is what? If 10.20 meter. Since it is a converging length, the focal length of a converging length is always positive. So we don't have to change this to a negative value, and we use our magnification formula: image distance over object distance. With that, we have M, which is 2.5, equals to V over U. If you cross multiply, you're going to have what? V equals to 2.5 U. And with this, we can begin to put in our what? Our length formula. So 1 over F equals 1 over U plus 1 over V. So our 1 over F is 1 over 10.2 equals to 1 over U plus, instead of writing 1 over V, since we have said that V from magnification is 2.5 of U, so we're going to write what? 2.5 U. Here we solve this right hand side, and what are we left with? The SM is obviously 2.5 U, and U goes there, it will give you what? 2.5. This goes there, it will give you 1, and this is going to be 3.5 over 2.5 U. equals to what? Equals to 1 over f, or rather 1 over 10.2, since our f is 10.2. So 1 over 10.2 equals to 3.5 over 2.5u. We cross multiply. So 2.5u equals to 3 times 3.5 times 10.2, and we have 35.7. So we divide both sides by 2.5 so that u becomes 35.7 divided by 2.5. With this, you're going to get u as being equal to 35.7 divided by 2.5, and our answer is just 14.28 meter, meter, and that is option C. So option C is the correct option for question 77. Next. All right, the diagram above shows two waveforms x and y. If the frequency is 30 Hz, what is the frequency? If the frequency of x is 30 Hz, what is the frequency of y? So we have the diagram. So for clarity, I will draw the diagram again and see how we can solve this if we have a question like this. So we have a waveform. We have a waveform, and there are two traveling waves. These are x, and what happens? We have y, and this is what? Y. Let's put the y here and y here. However, it is not that good, so I can make it broken so that it looks imaginary. All right. Now, when we look at this, there is a kind of interference that actually happens between what? X and y. Let's look at their source. They pick up at the same point, and they are actually interfering at this point, Then there is a relationship between what? X and y. Let's now try to establish such a relationship. The question says the frequency of x is what? 30 Hz. Frequency of x equals to 30 Hz. And don't forget, by definition, we say frequency is reciprocal of what? Of period. Is reciprocal of period. Definitely, I can say C equals to 1 over F, which is what? 1 over 30, and this is what? 0.3033, and that is going to be what? Seconds. That is the period. So we have the period of what? Of x. So period of x, we have it to be what? 0.033 seconds. If the period of x is 0.033 seconds, what does period say? It is the time taken for a complete oscillation. Meaning, for x to travel from here down to this place, that is a complete oscillation, it took x 0.033 s. However, we ask ourselves, within this time period, how many times does y travel, or how many circles did y complete when x completed a circle? You can take a look at this. This is the first circle and the second circle. It means it will take y 2 circles to complete what? To complete 0.033 seconds. For one circle, if it it will take, because it is of the same time on the axis. So if it will take y, if it will take y 1 over 0 points 1 over rather 0.0033 seconds, all by what? All by 2 to complete a cycle. So why do I have to say divided by 2? Because it completed 2 circles within this time period. You can see the first circle, the second circle. So we say definitely if it took y the same period, which is 0.033 seconds to complete 2 circles, then to complete a circle, it will take it half the time it took y, it took x rather. Then we can say definitely the period of y is same thing as what? As 0.0167 seconds. That is the period of what? That's the period of y. However, the question did not ask us for period, it asked us for what? For frequency. We go back again. Don't forget I said that frequency of y will now becomes what? 1 over period of y. That is equals 1 over 0.0167 hertz. And this is going to be frequency of y equals 1 over 0.0167 hertz. And this is what? 60 hertz. That is the answer for that. So the correct option is option C, which is what? 60 hertz. Next question. Question 79. Which of the following eye defects can be corrected by cylindrical lenses? Which of the following eye defects can be corrected by cylindrical lenses? A. Presbyopia. B. Chromatic aberration. C. Myopia. D. Astigmatism. It is actually astigmatism. What is astigmatism? It's a defect of the eye that makes the what? The eye, the eyeball or the lenses of the eye to look what? Instead of being spherical, it bulges as if it is an oval, or it looks like what? A rugby ball. And in that case, the eye cannot what? The rate at which the eye see any objects in front of an eye will be what? Will appear to be bulged. And as such, to correct that, we use what? Cylindrical lenses. Next. Question 80. A spectrum of sunlight is said to be impure when A. It is made of only 3 colors. B. It has no red color in it. C. The different colors in it overlap. D. It does not contain white light. We all know that what? A white light is what? Is a polychromatic light, meaning it has other lights of what? Of different wavelengths imposed or coming together to form that white light. However, we call it an impure spectrum whenever there is what? An overlapping. Whenever there is overlapping of different colors, that is when we say it is what? An impure spectrum. So the correct option is C. The different colors in it overlap. That's when it is what? Impure. Next. 81. A cell of internal resistance 2 ohms supplies current to a 6 ohm resistor. The efficiency of the cell is what? So we have cells. So we have a cell of internal resistance 2 ohms. So the internal resistance of the cell, that small letter R, is what? 2 ohms. That is 2 ohms. And it supplies current to 6 ohms. So that is external resistor, capital letter R, and that is what? 6 ohms. So the efficiency of the cell, don't forget that when the internal resistance of the cell is going to inadvertently affect what? It is going to affect the efficiency of the cell. So we always want to have a cell with no internal resistance or very little internal resistance. So the efficiency of cell will be what? Internal resistance, or let me say small letter R, over external resistance times what? 100%. That's another way, because the internal resistance is going to lead to what? To energy loss, and this is going to be 2 by 6 all by 100%. So let's take a look at this and see what happens. 2 by 6, and this is going to be what? 33.3%. So the answer is what? 33.3%. That is what? The efficiency of the cell. Next question. A particle is injected perpendicularly into an electric field. It travels along a curved path as depicted in the figure above. The particle is what? Now we have an electric field and there is a particle that travels into the field. Alright, you all know how an electric field behaves. It behaves very similar way with what? With a magnetic field. Now we have some point charges and we have the field created. So there is an arrow that points up, and there is a particle that was sent into this. However, when it goes to this line, it got deflected, and you can see the motion became what? Became deflected, and in such a way the arrow comes this way. However, we need to know the charge here, because the arrow is moving up. It means that what? There is a positive charge here and there is a negative charge here. So this is a positive charge down, this is a negative charge here up, because the direction of a point charge is such that it moves from the positive to the negative. So we say definitely this body, for it to be deflected towards the positive, it must be a negative particle. If it had gone up, then it would have been a what? A positive particle, because by electrostatic like charges we what? We repel, unlike charges we what? We attract. So let's look at this. A gamma ray. Gamma ray is out of the equation because gamma ray has no what? Has no charge. And as a matter of fact, when you subject gamma ray into an electric field or a magnetic field, it isn't going to do what? It isn't going to deflect. B, an electron. An electron is negatively charged, so it's possible it is an electron. However, let's go and look at other options. A neutron has no charge. B, a proton is positively charged and it will never deflect towards the positive side. So the correct option is an electron. B is the correct option. Next. 83. A thin film of liquid is trapped between two glass plates. The force required to pull the plates apart will increase if the what? A, surface tension of the liquid is reduced. B, perpendicular distance between the plates is increased. C, area of the liquid surface in contact with the plate is increased. D, pressure of the air is decreased. And you just take a look at a case where what? A thin film of liquid is trapped between two glasses, and you want to do what? The force you want to separate it is going to what? It's going to increase if you actually do what? If you actually increase the area of the liquid surface in contact of the plate with plates. That is simply because if you increase the area, it means that what? Don't forget, force pressure is force over area, and force equals what? Pressure times area. There is an inherent pressure in this two surfaces in contact, and whenever you increase what? The area of the liquid, you are going to increase what? The pressure, the force is required to put them apart. So the correct option here is what? Is C. Next. Question 84. From the kinetic theory of gases, temperature is what? We all know this is a statement that you must have learned from your first time, first classes you had in your senior secondary school. And this is just a kinetic theory of what? Of matter. And it says what? A temperature is the measure of the average kinetic energy of a particle. If a particle gains temperature, then its kinetic energy is increased. All right, let's take a look at the question again. From the kinetic theory of gases, temperature is what? A form of energy, and it's proportional to the total kinetic energy of the molecule. It didn't say temperature is a form of energy. However, heat is a form of energy. It's only temperature is never a form of energy. Temperature is just a measure of what? Of the degree of coldness or hotness of a body. So it is not a form of energy, and kinetic theory will never tell us that. B, form of energy. It is not a form of energy. So any option that has to do with form of energy, you have to remove it out of the possible or likely options. C, physical property. Yes, temperature is a physical property, and it's proportional to the total kinetic energy of the what? Of the molecule. It did not say it is proportional to total kinetic energy. It says it is proportional to the what? Average kinetic energy of the particle. So it's not the total kinetic energy. So that option is also going to be ruled out. The last option there is D, physical property, and is proportional to the average energy of the molecule. That is the correct option. So the correct option here is going to be D for question 84. Next. Dispersion of light by a glass prism can be reversed by, if you want to reverse the dispersion of light, you don't want the constraint of white light to be separated again, you want them to be recombined together. What do? A, reversing the direction of the light? No. B, another prism is placed upright beside the first prism? No. C, another prism which is inverted and placed side by side with the first prism? Yes. If you do this, you're going to recombine the what is just, you are reversing the first process of dispersion, you recombine it, and you are going to have what? A white light. B, placing glass beside the prism. And you cannot place a glass beside the prism and expect the white light to recombine. No. So the correct option for question 85 is C. Next. 86. Two insulated charged spheres of different sizes are carrying opposite charges are connected together by a metallic conductor. Current will flow from one sphere to the other until both spheres, when you have two insulated charged spheres of different sizes and carry opposite charges and they are connected together by a metallic conductor, what happens? Current will flow only when their potentials are equal. When their potentials are equal, that's when currents will now flow. All right. So A, carry the same magnitude and sign of charge. B, are the same potential. C, are the same temperature. D, are of the same size. So the correct option is what? Are of the same potential. Next. 87. When a number of identical small magnets are arranged in a line, the strength of the resultant magnet A is largest when they are arranged end to end. B is greatest when they are arranged parallel with light poles adjacent to each other. C depends only on the number of magnets provided they are parallel. D is greater when the magnets are arranged on the wooden surface. The correct option is what? Is A. It is largest when they are arranged end to end, because it's going to be a kind of what? A kind of resultant forces. Mind you, at each of these poles is a what? Is a force that is strongest at what? At the poles of each of these magnets. So when you arrange them end to end, you're actually increasing the resultant force or the resultant magnetic force you get from there. Next. So 88, a bar magnet is most effectively demagnetized by, you can demagnetize magnets by different methods. You can demagnetize a magnet by hammering it. You can demagnetize a magnet by taking it through a temperature. As a matter of fact, no magnet will withstand its magnetic property at a temperature known as what? Curie temperature. Curie temperature is about 5,000 degrees Celsius, and anything you heat up to this temperature is not going to retain its what? Its magnetic property. That's another way of what? Of demagnetizing a magnet. And you can also put it in a what? In a coil of, in a solenoid, and withdraw it gently from the solenoid in the east-west direction. East-west direction. Take note of that. So to demagnetize, you place that magnetic substance in the what? In a solenoid, and you withdraw it over a long distance in what? In the east-west direction. Let's take a look at the options. A, placing it in a northeast position and hitting it with a hammer. No, you don't place it in a northeast position, and that will not demagnetize the magnets. B, subjecting it to an electric current from a battery. No, that will not do that. C, bringing its north pole in contact with the north pole of a very strong magnet. That will just result into what? A repulsion. It does not going to, is not going to what? Demagnetize the magnet. B, hitting the what? Hitting the magnet. If you hit a magnet, like I told you, it is the most effective way of demagnetizing a magnet. No strong magnet will be heated up to a Curie temperature of about 5,000 degrees Celsius without it losing its what? Its magnetic property. And that is the correct option. D is the correct option for 88. Next. 89. Shadows and eclipse result from the, I have said that in one of the questions we solved before now. So what? When you are thinking of what? Rectilinear propagation of light, we usually use shadows and eclipse to explain the rectilinear propagation of light. And what is rectilinear propagation again? Let me bring it back to the memory list. That I told you that rectilinear propagation of light is what? Is the phenomenon in which light travels through a straight line. And that's, let's take a look at this. Refraction of light, no. B, rectilinear propagation of light, that's just the correct option. So that's B is the correct option for 89. Next. Which of the following is associated with alternating current only? Which of the following is associated to alternative current only? A, transformer. B, lead acid accumulator. C, induction coil. D, transformer. Oh, we have two transformers there, and maybe the examiner wants us to be sure if we're actually going to choose transformer. However, we'll do justice by looking at all the options and analyzing them, their relationship with either AC or DC. Let's take a look at the transformer. A transformer is a what? Is a device that takes in AC. You don't transform a DC source. You only transform what? An AC source. Because transformer works on the principle of what? Electromagnetic induction. It works on principle of electromagnetic induction, and there will be no resonating frequency in DC. That is why DCs are generally not what? Transformed. However, there is only a way to design a transformer, and it will work for what? It will work for a DC. This was done by a scientist popularly known as what? Rumcock, and he calls the transformer induction coil. This time around, it's not going to work on what? On AC. It's going to take in what? DC. And generally, they are used what? In the starter kit or starter of your popular, most automobiles, they use that. Especially the what? The gasoline automobile. So the induction coil is the DC version of a transformer. If you hear the word transformer, is for AC. If the induction coil is for what? Is for DC. Lead acid accumulator. Acid accumulator does not have anything to do with what? With AC. It's what is giving you is what? Is a DC current. So the correct option is what? Transformer. Either A or D. Next. 91. Calculate the distance between point X and Y with coordinates 3, 5 and 7, 9 respectively. So we have to look for what? Distance when we're given points. However, we need to know that this 3, 5 means what? X, Y. So the X is what? X1, Y1, X2, Y2. X1 is what? Is 3. Y1 is 5. X2 is 7. Y2 is what? 9. And here the distance between X and Y is given by the formula open bracket x2 minus x1 all squared plus y2 minus y1 all squared. And here we can do justice to it by putting in our values. And this is just going to be what? X2, which is 7, minus x1, which is 3, all squared, plus y2, which is 9, minus y1, which is 5, all squared. And what are we left with? We are left with 4 squared here, plus what? Plus another 4 squared here. And this is what? Square root of what? 16 plus 16. And this is what? Square root of 32. And we can see we have no square root of 32, so we have to break it down into something root of something. So you can see that if you take 32, this same root 32 can be said to be root of what? 16 times 2. And at that, we have root of 16 is 4, and root of 2 remains 2. So units. So that is our option is 4 root 2 units, and that is our answer. Option B is our answer. 4 root 2 is the answer as to the distance between x and y. Next, 92. The types of motion exhibited by a drum rolling steadily down an inclined plane are. Now, when a drum rolls steadily down an inclined plane, the words used in these questions are very important, and we need to understand the words used in the question before we can do what? We can know what the question is actually talking about. All right. It says the type of motion exhibited. We know we have a lot of different types of what? Of motion. By a drum rolling steadily. The word steadily, the word only means what? We have rotational motion. But the word steadily means what? The drum is not going to vibrate along its way down the inclined plane. And having gone through the rotational motion on the inclined plane is obviously going to cover a distance that we can call translational. So it is both rotational and translational. The fact that the word steadily was used means we should zero our mind from considering oscillatory or vibratory motion to be undergone by the what? By the drum. So the correct option is going to be what? Rotational and what? Translational. And I think we have that. So C, D rather. Okay. Question 83. One of the advantages of friction is that it A. causes wear and tear in machines, B. increases the efficiency of machine, C. increases the motion of an object, D. makes car tires to have firm grip on the road, E. produces heat in engine. It is what? Is that it makes car tires to have firm grip on the road. If not because of friction, we wouldn't even be work as human beings, talk less of cars. So it is because of friction that car tires were able to do what? To firmly hold grip the road. D is the correct option for question 93. Next, question 94. A car traveled with an average speed of 120 km per hour for 30 minutes. Calculate the distance covered by the car. Now, we first look at our options before we know how to approach this problem. Because our options all are in what? Kilometers. We don't need to convert to meters. So we just use the kilometer as our what? As our standard here. So let's take a look at the parameters given to us. So we have a car with an average speed of, so average speed is average speed equals 120 kilometer per hour. And you do that for time t, time equals to 30 minutes. Now because of the per hour, we cannot use 30 minutes with hour. So we have to do what? We have to change the 30 minutes to what? 30 minutes to hour to hour. How we know that 1 hour is what 60 minutes. So if we have 30 minutes, it means that what time will be what 30 over 60 hour, and this is what this is 0.5 hour. This is what we can use. And don't forget, distance is what distance is average speed times time. So we are going to have what 120 times 0.5 all in kilometer, and this is simply what 60 kilometer. So the correct option is option C, 60 kilometer. Next, 95. We have some graphs, and these graphs we have the first graph that looks like, let me replicate the graphs for better visibility, and you have the first one, and it's just down here. You have the second one, and just goes and comes down. The next one, and it goes down here, it comes down, and last, okay, we still have another one, and it is just like this, and last but not the least is what is this one that comes like this. All right, the following are the graphs that you have, and the question is asking for these are velocity time graph, time, velocity time, velocity time, velocity and time, and the question is asking in which of the velocity time graph below is the acceleration non-uniform. All right, let's see how it works. Here you see that the acceleration here is uniformly accelerated and then decelerated. However, this is what deceleration. There is an acceleration here, there is a deceleration here. Here it is a constant speed, then deceleration. Here it is what an acceleration, but it is what it is not constant because it's a curve. If it were to be a straight line, it would have been considered what a constant acceleration. Here it is simply what a deceleration. So to choose the option here is simple, but you have to be what you have to be very careful because you might likely fall, a prey to logic in this logic reasoning in this kind of question. So here is deceleration, but the question says acceleration. So this is out of it. Option A cannot be. The option B is both acceleration and deceleration, so it can never be. Option C is deceleration, it can never be. Option D is an acceleration, but this time around it is not uniform. So the best option or the correct option is what? Option D. Next. 96. Which of the following pairs of quantities are both vectors? We have said that vector quantities are quantities that have both magnitude and direction. Let's see. Displacement is a vector quantity. However, density is not a what? Vector quantity. So we want the one that are both what? Vector quantity. Energy is never a vector quantity. However, momentum is a what? Vector quantity. Power is not a vector quantity. However, force is a vector quantity. Volume is not a vector quantity. However, velocity is a vector quantity. And we look at the last option. Weight and acceleration are both what? Vector quantities. So the correct option is option E. Question 96. Option is what? E. Next. 97. A body immersed in liquid will float when it displaces volume of the liquid equals to, if it floats according to the principle of flotation, then it has displayed the volume of liquid that is equal its own what? Its own weight. So the first option says equal to a quarter of its weight. No. B equals to its own weight. That is the correct option. That is B. Next. 98. A ball is thrown with an initial velocity of 35 meters per second at an angle of 20 degrees to the horizontal. Calculate the horizontal distance covered by the what? By the ball, given that acceleration to gravity is 10 meters per second square. So what is another name for the what? Horizontal distance covered by a projectile motion. We call it what? Range. So it is what? Range. Let's see, there is a formula for range, and we say R equals to what? U square sine 2 theta all over G. That is the formula for what? For range of a projectile. And we say R equals U is 35 square sine 2 into 20 degrees all over 10. And here I am going to have and that is 78.74 meter. 78.74 meter is my correct option. That is option D. Next. 99. The relative density bottle weighs 0 kilogram when empty, 0.1 kilogram when filled with water, and 0.2 kilogram when filled with a liquid. Determine the relative density of the liquid. However, we know that relative density is what? Weight of liquid over weight of water. That is relative density. So we say it is going to be relative density equals to weight, or we can say mass. Let's use mass because the parameters given to us is mass. So mass in fluid over mass of water, equal volume of water. Moreover, mass of fluid over mass of equal volume of water. And when you check that, it gave us 0.10 all over 0.20, because kilogram we cancel kilogram, and don't forget that's of water is 0.10 and the other one is 0.20, so it is 0.20 and what? 0.10, and this will give you what? 2. So the relative density of the liquid is 2. So the correct option is option B. Next. Question 100. A body performs simple harmonic motion at a frequency of 60 Hz and an amplitude of 2 centimeters. Calculate its acceleration at the end of the path of oscillation. So this is a problem that we can just write out our parameters. However, we know that what? When the question has to do with acceleration is what? Is omega squared A, where omega is what? Is angular velocity. So what is angular velocity? It is what? 2 pi f all squared times your amplitude. That is, if we multiply our amplitude by our omega square, we need to get acceleration. We are given frequency f equals to 60 hertz, and amplitude capital letter A equals to 2 centimeter. However, we cannot use 2 centimeter. We have to convert to meter. This becomes 0.02 meter. We divide centimeter by 100 to convert to meter. Calculate its acceleration at the end of the oscillation. Don't forget that we only need frequency and amplitude to get acceleration. So acceleration is going to be omega square, that is 2 pi times frequency 60 all squared times 0.0210 meter per second square. When you do this, 2 pi and this is what? This is 2.84 times 10 raised to power 3 meter per second square. That is the what? The acceleration. And the correct option is going to be C. Next.